Have you ever stopped to think that right now, at this very moment, you're surrounded by colors you'll never see? Not because they're hidden behind walls or locked away in a box, but because your eyes simply can't detect them. Our vision feels complete. We can tell red from blue, green from yellow, and even spot subtle differences between shades. But here's the surprising truth. The colors we see are just a tiny fraction of what's actually out there. It's as if you've been reading a book your entire life, only to realize that most of the pages are invisible. So why is our view so limited, and what exactly are we missing? To answer that, we need to take a step back and look at what color actually is. Color isn't a property of objects. It's a story our brains tell about light. When light hits an object, some wavelengths are absorbed and others are reflected. The ones that bounce into our eyes are turned into electrical signals, and our brain interprets those signals as color. But here's the catch. Our eyes can only detect a very specific range of light wavelengths known as the visible spectrum. This spectrum is ridiculously narrow. Imagine a ruler stretched across the entire United States from New York to Los Angeles. If that ruler represented the full range of possible electromagnetic wavelengths in the universe, the portion we can see would be smaller than a single human hair on that ruler. Everything else is invisible to us, not because it isn't there, but because our eyes simply weren't built to detect it. The light outside our range is called ultraviolet, infrared, radio waves, microwaves, X-rays, gamma rays, each with its own colors that we'll never see without technology. So if our eyes are such limited instruments, why do they work the way they do? The answer lies in evolution. We didn't develop eyes to see the entire electromagnetic spectrum. We developed them to survive. Our ancestors needed to spot ripe fruit among leaves, see predators in the grass, and navigate under daylight. The sun emits most of its energy in the range we now call visible light. Evolution tuned our vision to this sweet spot because it offered the most useful information for survival. But other creatures live in different realities. Bees, for example, can see ultraviolet light. To them, flowers look dramatically different, with UV patterns that act like runway lights guiding them to nectar. Snakes can detect infrared, letting them see the body heat of prey even in total darkness. Birds can see far more shades of color than humans because they have 4 types of color receptors in their eyes instead of just 3. That extra receptor lets them perceive colors we can't even imagine, colors with no name because they don't exist in our experience. And here's where it gets even more fascinating. Our eyes use 3 types of cone cells to detect color, one sensitive to short wavelengths, blues, one to medium wavelengths, greens, and one to long wavelengths, reds. Every color we see is a combination of signals from these 3 cones. But with just 3 inputs, there's a limit to the number of distinct colors we can distinguish. Estimates vary, but it's somewhere around a few million. Sounds like a lot, until you realize that adding even one extra cone type, like some birds have, could multiply that number many times over. If you could suddenly see colors in ultraviolet, the world would look alien. Everyday objects would be painted with patterns you've never noticed. The skin of certain fruits would glow with hidden signals. Some flowers that look plain to us would explode with complex markings visible only in UV. Even your own clothes might surprise you. Detergents often contain optical brighteners that reflect UV light, making them look brighter to human eyes, but under UV vision they could blaze with an otherworldly glow. The same goes for infrared. Infrared light reveals the heat of objects, so you'd see the world in terms of temperature as well as color. A fresh cup of coffee would shine like a lantern. Footprints on the ground would remain visible as warm shapes for minutes after someone walked by. Sun-warmed rocks would glow long after sunset. This isn't science fiction, it's everyday life for animals like pit vipers and some beetles. So if all this light is bouncing around us all the time, why can't our brains just learn to see it? The limitation isn't just in the brain, it's in the hardware of the eye. Our cone cells contain molecules that absorb light energy, and these molecules are tuned to specific wavelength ranges. To see ultraviolet, for example, our eyes would need special filters and pigments that respond to those shorter wavelengths. And there's another problem. Ultraviolet light is energetic enough to damage cells. The lens of the human eye actually blocks most UV to protect the sensitive retina from harm. In other words, evolution made a trade-off, protection over perception. But here's the twist. Technology can give us supervision. Cameras and sensors can detect infrared and ultraviolet, then translate them into colors we can see. Night vision goggles, thermal imaging, UV photography, they're all ways of peeking into the colors we were never meant to see. And when we do, It's mind-blowing. Astronomers use this trick to map the universe in wavelengths far beyond visible light. A galaxy might look ordinary in visible light, but in infrared it could reveal swirling dust clouds where new stars are being born. In X-ray light, it might blaze with the violent glow of black holes devouring matter. Each color band tells a different part of the story, like flipping through layers of a cosmic scrapbook. This is the part where the idea really clicks. Color isn't something that exists out there in the world. It's a language our brain invented to describe a narrow slice of reality. Other creatures, with different eyes, speak different versions of that language. The world doesn't look one way. It looks millions of ways depending on who's looking. And the version you and I see is just one translation. Here's a thought experiment. Imagine you wake up tomorrow with a brand new type of cone cell in your eyes. Suddenly, your brain starts processing wavelengths it never has before. At first, it would be overwhelming. Colors you've known your whole life, red, blue, green, would be surrounded by entirely new shades that don't fit anywhere in your current vocabulary. The grass wouldn't just be green, it would have an extra layer of detail like a hidden texture made of color. The sky wouldn't just be blue, it would be laced with patterns of hue you've never experienced. And yet nothing in the physical world would have changed, only your perception. This is the strange power of vision. It doesn't just show us the world, it creates the version of the world we live in. This is why scientists sometimes say, we don't see reality, we see a model of reality. Color is one of the clearest proofs of that. Now, knowing this, you might wonder, if there are millions of colors we can't see, are we missing out on important information? The answer is both yes and no. For daily survival, our limited range works just fine. But in specialized situations, science, art, navigation, access to more of the spectrum can reveal game-changing details. Farmers use drones with multispectral cameras to see plant health in wavelengths invisible to humans. A field might look fine to our eyes, but in near-infrared it can reveal stress in crops days before it's visible. Doctors use imaging in different parts of the spectrum to detect diseases early. Archaeologists have found entire lost cities by scanning the ground in infrared, which shows subtle differences in soil composition. In these moments, the invisible becomes the key to discovery. And here's the fascinating part. The invisible colors aren't just out there in exotic places, they're bouncing off you right now. Your skin emits infrared. Your clothing might reflect ultraviolet. The sunlight coming through your window contains far more than your eyes will ever detect. The world around you is like a symphony, but we're only hearing one instrument. Technology lets us hear the rest. The moment you see an ultraviolet photograph of a flower or a thermal image of your own hand, you realize something profound. What you thought was the full picture was just a cropped, filtered version. The aha moment is realizing that our vision isn't the limit of reality, it's the limit of our own biology. Once you understand that, your sense of the world shifts. You begin to imagine what other creatures are experiencing. To a bee, a daisy is a neon landing pad. To a snake, a mouse is a glowing beacon of heat. To a bird with ultraviolet vision, the sky itself may have gradients and features we can't begin to visualize. These differences aren't just fun facts, they're reminders that reality is richer than any one viewpoint. It's also humbling because it means that every time you think you see things as they are, you're actually seeing them as your body allows. If humans had evolved in a different environment, say on a planet with a cooler, redder sun, we might all see infrared naturally, and our art, design, and language would be built around that spectrum. Our idea of normal is just what worked for survival here under our sun in our atmosphere. And here's where the curiosity kicks in. When you realize your eyes are just one kind of sensor, you start to wonder, what would it be like to live in a body equipped to see the full spectrum? Could we even handle it? Or would it be like trying to listen to every instrument in an orchestra at once without knowing which melody to follow? This is why color is such a powerful subject. It sits right at the intersection of physics, biology, and perception. It's a reminder that nature doesn't just set the rules of the game, it also chooses which parts of the game we get to see. And technology? That's our way of peeking behind the curtain. So the next time you're looking at a sunset, remember, the colors you're admiring are only a fraction of what's really there. Somewhere in that light are ultraviolet patterns invisible to you but dazzling to a butterfly. There's infrared warmth still radiating from the ground, painting a completely different picture. And all of it is part of the same reality, one that your eyes are just giving you a translated, condensed version of. Once you see the world this way, you can't unsee it. Every shadow, every reflection, every glint of light becomes a hint of something more. It's an invitation to keep asking, what am I missing? And that question is where all science begins. If you've enjoyed unlocking this invisible layer of the world, imagine what else is waiting to be revealed. That's exactly what we do here. Take the everyday and turn it into a portal to the extraordinary. So like this video, share it with someone who thinks they've seen every color there is, and subscribe to How It Actually Works. Because your curiosity is the lens, and we're here to widen the spectrum.